I don't know, this is the magic room, which sometimes the recordings doesn't work here. So try to pay attention. So thank you for coming, thank you for your questions with heavy homework that was intended for 2 weeks, but those who did it in the last day maybe experienced a little stress. So the procedure for the class remains the same. Very soon there will be practice of democracy, where everyone will elect a subject for presenting something on the skills of operating master. So from this point of view, you may think ahead and either record what you are doing during the labs, or when you do something that you like and you consider it as possible subject of presentation, keep an open PowerPoint where you copy paste whatever you do on the screen. It will save you time later. Generally, I hate homework so much at both sides of the career, but here we need to do a few because semester is limited in length, and we need to practice a couple of things. So the goal of the course, at least what was promised, and those who registered probably be with it, that the goal is to computationally characterize materials and molecules. And we are slowly approaching this goal. Like last presentations, some of you were showing how to deliver observables like ionization or infrared spectrum presented by Gage. And you do have an idea what's the connection between density of states, energy of gap, and color.
Density of states.
Gap?
Yeah, I know, yeah.
And color.
Yeah.
Good.
Okay.
Good.
Like where density states come from?
Density of states comes everywhere. It's like a basic thing to compute all the time.
Okay.
So there is I'm just giving a little disclaimer. I realize that you feel a little discomfort of logging into a sequence of clusters. And if it is a big discomfort, basically all procedures can be done only on photon, if it is like a couple of atoms system. But we are doing this log into larger system with a purpose. Since you're in this course, you may have in mind some ambitious research project that needs to be done with computation, and you need resources with a very productive environment that can do larger systems or some extensive computations. So why don't we try things like that right away? So this is a little reason why you suffer logging in and transferring files. So what is the program for today's meeting? Absorption spectra is like absolute minimum. We definitely cover it no matter what. What else did I promise?
Boundary conditions.
Boundary conditions and
Ions.
Or orbitals.
Orbitals.
Ions. Dispersion. Heat. And MD is likely for next Wednesday in a week.
Can we do pressure? Was one pressure one?
Yeah, pressure will be here. It's,
okay.
You do not need to learn anything. It is automatically computed all the time. I can answer it right now. If you compute something and you do grep space pressure or just press, it will tell you what's the pressure on your simulation. So
And we're doing this all in vacuum, not solvent?
No electrostatic polarizable continuum media.
Okay.
If you need solvent, you add it explicitly.
Okay.
So there will be homework that I will formulate and distribute, but basically it will be computing absorption spectra of several things and including new models that we will create today. Before we go into practical things, there is another disclaimer. If you have in mind using the skills that we are getting here for your say personal pleasures or your career and research that you do outside of the class, you may follow what Mary is doing. Look at her. Most of us are using these computers that are sitting in the room, right? And here is the personal laptop. It's very smart, because then you get used to the environment, you can install additional things, and you can do everything. So card does the same, right? Good choice. So for computational chemistry, one doesn't need a wet lab, one can do research laying on a sofa. Right? But then if you do not need to pull the equipment from the classroom. So I don't care for success of the class, but you may decide to bring laptops and start installing a right environment there. There is also, for orbitals, I will get through anyway, but there is a piece of software that is not installed on these machines and is not very optimal to go through remotely. So you may consider to install it on your personal machines, personal laptops, VMD. So it's a really good visualization software that will make your life extremely pleasant in aspects related to visualizing orbitals. So its quality of images will be better than Gauss view. Okay. While I'm mumbling these introductory things, you may want to download mobile extern, log into Photon, even log into NERSC, and make sure that it doesn't close us, so that when it will be time to do something, you do not waste time on it. And this is the command you use to go to the query server, right? If you have completed the homework, then probably it is a certification that you were aware of this command. Right? So while being on a Photon, add this username, type this string, or record it somewhere because it is useful. Also, when you log into Photon, you know this trick when you do arrow up, it remembers commands that were done by you before, right?
Or your cat.
Right.
Yeah.
So if you do arrow up substantial amount of time, you will see this command. If you confident or comfortable to recall it, or if you you know, all these commands are very sensitive to little typos. If you change one of the letters, it will not work. So, like not MERSC or BERSC, it is MER, whatever.
And you can go to Edison too, right? I mean,
Edison will be retired soon, but yes.
okay.
Yes, there are two active shoulders of the NERSC, Corey and Edison is a little bit obsolete, but it's still much more powerful than anything in the world. People try to migrate from Edison to Corey, and Edison is less occupied. The queues are shorter there.
Right. I actually tried to get into Corey, and it was down for maintenance. So that's why it's like you can go.
Yes,
the other
yes,
way
that's
down.
smart. That's smart.
Uh,
Yes.
So do I change my working directory to the path specified by lower space square one?
More space, what?
Where one, W-H-E-R.
Let me do some correction for the class. Because war1 is only for one person who did it. Let's copy war1 into war2 and do vi war2. So we do not need all this stuff. I would say this way, and then append your name at the end. More word to CZ. And that's how you. Okay. So here is something that you remember from the time when you enjoyed the homework, right? You do, upon completion of the healthy was job. Well, there was like some people. There are different tastes. Some people hate measuring interatomic distances and angles. Some love. Most hate. This was done in purpose so that as a chance to control that this stupid robot computer doesn't give you crazy geometry. Sometimes, especially if you set up for t value too large, like more than 2, it will explode and all atoms will be found randomly in different corners of the cell, and the electronic structure will be crazy as well. So it's a good practice to check for geometry at each steps. So I'm not going over things we did before, just quickly skimming through. There is an extractor for this that you run it and it extracts a list of orbitals, places it in the file energy pop, and you copy it into states. If you hate this extractor, you can just manually copy paste right segment of the out card, and then you measure how long, how many lines are in this state, and later on it will be used for code that creates those. Then you do grep Fermi, and it gives you these numbers, and then you can also extract number of electrons and number of ions, right? Which are, it's not super important. The code for those will work even if you put the random numbers like 1 or 1,000, but it is needed in order to adjust height so that you compare, you're able to compare systems of all different sizes. It basically divides by number of atoms and number of electrons. So dress DOS norm will, it's not an example of good user-friendly code. Typically, even command lines codes ask all parameters from the command line or from the input file. And here is a little ugly way when it starts a dialog. So you need to type in number of states, where you start your DOS, where you end, Fermi energy alpha plus beta, width, magnitude, number of atoms, number of electrons, and some number for bulk phase. So it is what you got. Orbitals, we'll do them later today, I hope very much. Okay. Do you have any positive memories about, I'm going to walk there. If you didn't, positive memories of last lecture before the spring break? Or little recital of this recall, remembrance, refreshment?
Remember this being thrown out.
Oh, this I like at most as well. So yesterday we had like lecture number 17, and before the break we had number 16. What do you remember? Or do you remember anything positive except symbol of completion?
I just remember you showing us the assignment in particular. That's all I remember.
That's practical. But was there anything else?
Once you say it, I'll be like, okay.
Huh?
I said, once you say it, I'll be like, oh yeah.
Ah. Nathan, what did we do before the break? No, you should remember. I'm considering you as a theorist who is either drawing Feynman diagrams every day or will be doing it the next couple of weeks. No? We were doing observables from Hartree-Fock and considering the interaction of light with matter, right? And we do need this today. So media is going to say, "Oh yes," right?
Oh yeah.
So optical excitation of electron from orbital 2 to orbital 3, right?
Don't forget your hole.
Don't forget what?
Your hole.
Yeah. Okay. Thank you. So what was the main message in there?
The atom absorbs some energy.
Molecule. Atom is too narrow.
Some molecule absorbs energy and electrons move.
Well, it may not move in space, but it gets into different quantum state.
Okay. I didn't know. Thank you for clarifying.
Sure. How many electrons is typically in the molecule? How many how many electrons is typically in an average molecule?
So the tiny maybe like 500?
One or more than one?
More than one.
More than one. Good enough. Philosophically. What's the wave function of system with more than one electrons? Maybe in 1 year, well, not this year, but next year, I should go back from projects to regular class arrangements with exams more frequently. What's the wave function of many for system consisting of many electrons?
The product of the single electrons.
You are a good descendant of Hartree. So you are declaring Hartree product. What's the difference in real life from Hartree product?
Real life's not that simple.
Yes. And electrons which are like fermions that cannot occupy the same quantum states. Pauli exclusion principle leads to, starts with letter A, of wave function. Not B. Let's play this bi-level game. A word that starts with letter A. Huh? Yes, antisymmetric.
Well, I guess.
So if you have more than one electron, wave function is antisymmetric. and any process is like really crazy object to find. And I do not put wonder. I do not put doubts that you can answer in the middle of the night if someone wakes you up. How to find observable if you have if wave function is available, right? You just take wave function on the left and right as a bracket and put operator for observable in the middle.
Mm-hmm.
Yep, it's nature. But if the wave function is multi-electron wave function, it's really hard. It's adverse procedure that we want to avoid. And for, on one hand. On another hand, optical absorption is major observable for some people. For some, maybe it's secondary, but it's really important. And finding expectation value of transition dipole between Slater determinants is really hard. So we are revising lecture 16. So this is hard. And what we spent time on telling that if it is initial Slater determinant, this one is final, and they differ only by promoting electron from like occupied to unoccupied orbital, then it will be equivalent to finding matrix element from this orbital 2 dipole element orbital 3. So from many electron one can get into one electron matrix element. Okay, so if it is what I was expecting you to answer when I asked what did we do on the lecture number 16, right? So there is a rather rigorous way how the matrix element of optical transition can be reduced to one electron matrix element between just one electron orbitals. There are corrections to this, but it is a leading term that is really good. So our practical things that we will be doing here will be based on this stuff. Okay? Good. So we do need orbitals. If you are fan of Gaussian, you do have check, form check, and cube files, right? Where are check, form check, and cube files in VASP?
There's a
Here.
wait.
I don't know why, but they put word car at the end of each variable. Maybe in Germany people like driving cars. Okay, so in the in-car you need to make sure that you have L wave equals true, so that the wave car is stored. It's analog of check, and it includes information about all orbitals. It is written same as check file in the non-human way. So if you try to read this file, do not do it, because your screen will be garbaged by. Okay, if you want to check how wave car looks like, ask Queenie. You may need to log off and log in, because sometimes it changes your coding system, and then when you start typing, strange symbols appear on the screen. So do not open it. So we do need to find absorption spectrum. And from your favorite lecture number 16, you know that absorption spectra are based on matrix elements of position operator, same as dipole, between pairs of orbitals, occupied and unoccupied. Good? If you are following traditional academic standards of learning, sitting and recording anything you do in class, you may record this verbalization because it's really good. So absorption spectra are based on matrix elements of position operator between occupied and unoccupied orbitals. Yes?
Do you have a video record or something?
Of what?
Of this graph?
Well, there will be a record if it will work. But in the past, I was trying to record everything.
Okay.
You can find it. But it changes from year to year. I hope to do the best, but maybe opposite. If it is opposite, yes, watching will be more useful than sitting here.
Can you repeat what you said again?
Absorption spectra calculation is based on computing matrix elements of position operator between occupied and unoccupied orbitals. Make sense?
Just a second. All right, got it. Thank you.
Yeah. Most people in the world would agree with that, but the advisor of Nathan may kick me if he hears it. Because some people are willing to improve quality of results for a couple of sig figs. But in leading term, it is correct. So, there is a code that will follow this verbal procedure. And right now we will go over practical steps, but later on, when you will be writing written reports or when you will be doing like computation for your own benefits and research, you may look for and put some equations. So we will be practicing this equation in the following form. So initial orbital predominantly occupied I, position operator, final orbital J, dr, integral, and we will call it mu ij. So transition dipole. Again, if you follow academic standards, old-fashioned academic standards, you may look in Wikipedia for definitions or remember from your previous course what transition dipole is. So what we will be doing is based on this concept. Okay? So we will be practicing computation of transition dipole matrix element. And as soon as you do have data for this transition dipole, you may compute later strengths, which will be for each pair of orbitals, and it will be proportional to transition dipole squared with some constants. And then the absorption spectrum of frequency. So all occupied, all unoccupied, Fij delta h bar omega minus Ej minus Ei.
And that's what makes for a pretty absorption spectrum.
Yes. So I will answer a question in a second. So we will be practicing this equation for each model. So when you do vast calculations, you get orbitals here and there. We will be computing this matrix element and through specific codes plugging in to get oscillator strengths, and then same as we did density of states. So we converted discrete energy values into continuous density of states. Here it will be discrete set of transitions, and through delta function we will continue to the absorption spectrum, which is continuous line. I remember you have a question. Please give me a little prompt if you had personal experience in operating UV visible spectrophotometer. 1, 2, 3. Okay, 4. Even if you are planning to do theory, you may practice it. It's not that hard, and it's one of the simplest experiments. Yes?
I have a strange question. Is the I and the J called like a coupling term, or is that?
No. It's just indices of orbitals.
Okay.
Kevin.
Okay, so phi sub I and phi sub j are orbitals.
I and J are orbitals.
Alright, so one is occupied and the other is unoccupied?
Correct.
Okay, so phi sub I is unoccupied?
Yes. Phi sub I is occupied, phi sub j is unoccupied.
Okay.
No one forbids us to compute matrix elements for between occupied and between unoccupied to unoccupied. But it is not needed for linear absorption. It is needed for like second order processes that are more exotic.
How would that look if you had I and then JJ instead of the I?
Not hard, but we shouldn't waste effort and add fog to already complicated.
This is going to be practical for our purposes.
Okay. So we will need to have energy pop file, which is the same as states. We will need to know the length of this file, and we need to create the file input overlap, which you may have already created, right? So it is just a way to communicate to the codes how many orbitals you have. So for this input overlap, you make a file with 3 lines. First line is your first orbital, number of first orbital. Second line is the number of your last orbital, and the third line is just number 1. Why it is needed? Right now we just blindly put first and last, but in the future, some of you may decide to work with systems that have like 1,000 atoms and 10,000 orbitals. And most of these orbitals will have energy like less than -20 electron volts or more than 10 electron volts, and will never contribute to optical absorption. Then you will narrow your range of interest. You will start from orbital number 3,000 and end at the 3,500. And the rest will be removed from consideration. So there will be a code introduced on the next slide, and we will practice it very soon, that will be called oscillator strength. It will contain the matrix elements of transition dipole and oscillator strengths that are needed for spectrum. So I'm going to switch to like online mode and typing commands very soon. I'm going a little bit ahead. So what to expect? So we will do some relatively simple commands, and by the way, in the recent email, I just put them in the body of the email, right? So it's not that hard. It will not take 8 hours. So upon completion of these commands, if everything is right, then your file oscillator strengths will look approximately this way. So it will be rows and columns, and each row will have the following structure. First 2 columns are number of occupied and unoccupied orbit, right? The third column will be value of oscillator strength. So ideally, if everything is perfect, oscillator strength shouldn't be bigger than 1. But sometimes it gets substantially bigger. there is no problem with this, just keep your eye for the future. Fourth column will be energy difference between these two orbitals, like if this is HOMO and this is LUMO and this is the gap. The example was done for titanium hydroxide that you practiced a lot. And here's the occupation of occupied and unoccupied. Occupied has 2 electrons, unoccupied 0. And here are 3, so position in 3-dimensional Cartesian space has 3 components, x, y, and z. Matrix element of position also has 3 components, x, y, and z. So those are 3 components of transition dipole between these 2 orbitals. Okay? And as soon as, probably I'll go to practical aspects, but with this information, one can build absorption spectra that is very well comparable to experiments. There will be, so in very soon, you will be able to predict outcome of UV visible spectrometry. Often, your computed spectra will coincide with what is measured on experiment. Sometimes it will be slightly deviated or substantially deviated, and then people like advisor of Nathan come into a game and tell like, oh, you have forgotten the correlation in the second order or whatever excitonic effects. But for the beginning, we do this simple thing. Good. Oh, I think I have printed some lines. So they're not literal, because I did it 8 years ago. And names of the codes were slightly updated, but it is just something to hold in hands and check it. So first command is oscillator strengths overlap. And in the here. Okay, this is the file that you've got in printed form, right? You recognize it?
Yes.
So here it is listed as OS dipole V3. And by the way, if you like Fortran and if you want to copy this any of the codes to your personal computer or other cluster, feel free. If you do it extensively, you may arrange some agreement, but if you do it minor things, you may guess. So .f will be the Fortran, and this one is executable. The one here is the same code, just slightly different name, which is on the NERSC supercomputer. So basically, you need to copy this command, go into the directory where you have healthy output of VASP, and just type it. Good. So I'm going to titanium. Oh, I have already computed it. So I'm doing here an example that was not pre-made, therefore it will be a little delayed, but you will. So I'm going to the directory with titanium hydroxide dimer. I believe that it does have successful completion. Okay, so I do see that in this file the number of orbitals ends at 31. So I'm doing overlap. Okay. And then I'm running X something, and then it continues automatically extract energy pool.
What was that command again for the global homes? There's a bin in there? Okay, so that's what we're missing with the bin, okay.
So, yeah, you're telling us that that is Fortran? I'm actually trying to actually log into the global predictors.
Oh, probably I need to make a circle and check that everyone is logged in, right?
Was
Give me a sign if it is needed. Okay, I will do a circle and check that everyone is logged in, and then I will continue.
So that's the message it gives you? That's okay?
No.
No.
Here is okay. And I'll do top so that it doesn't log me off. Let me make a circle and see that everyone is logged in. What are you doing? Why do you do this? First we need to see
CD, okay. I wasn't sure.
not for compact disk, but for change the
Oh,
We do have some directives. Let's make one. Directory and 2, 6 each. And then you just steal this.
wow. Wow.
Did you put the command in?
Mhm.
Did you put the command in?
For that last thing you showed us?
Yeah.
Just a second. some smart comment, but I have forgotten.
Okay.
Please help each other. Do not consider your classmates as competitors. As quicker we all get to the same page, the quicker we go together.
So are you, what do you have on you right now?
I'm in the area I'm supposed to be in, it's just the command's not working for me.
You're circling something. What were you circling?
Okay.
What are you
Like,
circling?
what did you type in here?
I just got to, yeah, to this.
Oh, you haven't gotten.
So what did you write down there?
Yeah, it's supposed to be global homes, catering, Ben, but I'm not sure.
I'm sure he'll show us.
Let me give you some. So, if I forget during the day, remind me. The nurse has some barriers for transferring files from outside computer to nurse. But if you are logged into there, you can transfer files by connecting from nurse to your outside computer. Okay? So you do not need not sending files from local to nurse. Sitting on a nurse, you pull information from your computer. You
Well,
just
no,
say
this is
to
where
your
you need to
computer,
be.
okay? I'll show you.
Then type this.
Yeah, but it's not working for me. This is gonna.
Let me just steal files.
Try to. Yeah, it's gonna be this. So.
We'd actually.
I found a very good one.
Oh, another little comment. Some of you have asked why are we going to so strange and long path of directories. The Photon has maybe like 20 users. CCast has maybe 100 users with active usernames. Nurse has like 20,000 users at least. And therefore, in order so that files do not intermix, one needs to have organized system of subdirectories. Therefore, it's a reason for this complicated system. Another thing, there are home directories on each computer systems, but typically they have very small quota. And this, where we are going to project directory, is typically assigned with larger amount of available space. Okay? So just for your curiosity. Okay, so you can work.
I've got it.
Hey Mary, what command did you use after you typed in that overlap.exe command thing?
I'm not sure. Tried that too. I'm not sure.
This one was the first one.
But
He did something. I just don't remember.
Yeah, and
I was trying to look at his.
Did you look it up?
I'll explain. I'll explain first.
okay.
Where were you?
Do you guys know? Did you get the commands? Okay. No. I got the same error. He got it and then he did something really quick and he got it working. I was like, what?
I'll put off the record, just in case, and then tell a little story.
Oh, please explain.
Oh, we need to go
Yep.
wavecar to wavecar old. And after that, this oscillator strength overlap exact, right? So right now it went in few seconds. If you will be doing it for bigger and bigger systems, it will take more and more time, and one day one may need to submit it through job submission systems if it like works for hours. But for small systems, it's instantaneous. So after you see, later on we can discuss what are the service numbers here. But the main thing that after completion, after you see this message, there should be appearing a file called oscillator strengths, right? And if you look on it, you see the style of information that you noticed in the slides. So initial and final state, value of oscillator strength, transition energy. So since it is titanium hydroxide that after post-fault ripening, after growing, it will convert into titanium dioxide, the value of a gap of about 3.2 electron volts is natural. DFT underestimates gap. If one would do corrections for this small molecule, it should be a little bigger. You know, Hartree-Fock overestimates gap, DFT underestimates. But merging these two things comes to hybrid DFT. Adding Hartree-Fock corrections to DFT called hybrid DFT, and then it gives very good corrections. So oscillator strengths, energy from occupied to unoccupied, and here are three Cartesian projections: dx, dy, dz for transition from 24 to 26. And I believe the records are arranged according to values of initial and final, and are also arranged according to the values of oscillator strength and energy. If by some reason, so very soon we will go to making spectra, and it will be easy. So we are doing slowly but surely. If you are more, if your mindset is more mechanistic rather than visual, if you don't care about spectra and talking to experimentalists, and these numbers are sufficient for you, you may plan to do a couple of tricks. For example, you can do sort minus 3 which means you rearrange this file according to the numerical value of the column 3, oscillator strength. So you find which transition gives biggest contribution to optical activity. And it will be from like HOMO -1 to LUMO +2, right? And the value is about half. And you can practice this thing also if you need 4, and you remove R. So sort with this key. G stands for these keys stand for sorting based on numerical value, and it is a column number 4. So now we arrange it based on the ascending order of the transition energy. So here is the minimal transition energy, which is from HOMO to LUMO. Right? If you put letter R here, it means descending, reverse. And if you don't care about numbers, just sleep, lean back, forget about it. So let's look on the
little piece of paper that you've got. So one little measurement you may practice WC, which stands not for water closet but for word count.
Word count.
And you need it just for running the subsequent code. So WC was strength 168. And then you run one of the codes from this family till the beam spectrum improved. So this little code is equivalent, is very similar to the code that we used for density of states, DRESS DOS, right? So it uses the value of oscillator strength and transition energy and addresses them with finite width approximation of delta function and makes continuous stuff. So I click on it and it asks for a number of and then it asks in which range of transition energies spectrum needs to be computed. So if you put 0, it may give you an error because sometimes it divides by this value. So start a little above 0. Why this is needed? Like if, who was practicing UVV spectrometer? David? Okay, you know that it shows signal only in certain range. It doesn't give you everything from radio frequency to gamma rays, right? It focuses on like optical range or here the same. You put in which range in electron volts you inspected. And we already know that in this model, lowest transition is 3.2. So we definitely shouldn't end at 3. You may start at 3 and end at 7 or whatever. So put some from 1 to, let's say, 7. Line widths, same meaning, thermal broadening of the lines. Enter HOMA. I think here it was 24. Now it shows that it has been successfully completed. So LS minus LT head shows that there is a file named spectrum. So I'm planning to make another round and see if you got this file. And if you hate GNU plot, you may download this file to your local computers and plot it with Excel. So I'll make a circle and check that everyone gets the file named spectrum.
Is it 3 or whatever?
Oh, just if you
start in first.
If you start editing,
So that 0.5 to 3 is like a ratio? 6?
Yes.
What?
It said a min of 0.5 and max of 3. Is that saying, because he just went to mine, put a min of 2 and a max of 4.
I'm not sure. I'm not sure.
Okay, no big deal.
I think that's for the program. It's allowable.
Yeah, but he put in 9 and it says
9?
minimum, maximum 3.
I don't know. I have no info.
I just typed in this spectrum.
further. You got
Oh,
it?
yeah, I got it. I was transferring the file. I got it.
Good. Okay, so I'm not insisting that anyone uses GNU-plot. It's just my favorite, my personal choice, and I think it is a little more comfortable for this command line operated things to avoid visualization until last minute. So what is next? So GNU-plot, GNU-prog, SPE. First, Sudipta may want to look what is inside. Right? Remember his talk on recent presentations. So it just plots spectrum using second line, which has energies as x, and third line, which is height of the spectrum as y. Right? And there are some additional things to make this PostScript file, like putting axis, setting range, making it like color. We do not need it, we can just blindly use it. And another thing, if you hit tab, you'll see that this family is a little bigger, and there are different versions of this little script that later on you may use, but this generic should be sufficient. So after you run it, there appears spe.ps, right? Which you ps to pdf.
You're saying new plot and then new prog?
Yes.
Okay.
Let me put it here. Yeah, here. It should be on your printouts. It didn't change through years. Let me bring it up. Okay, so here is the little dialog, and after, yeah, here, GNU-plot, GNU-prog. So we are on this line. I'm going to make another circle and check that everyone is on the same page.
So
Yeah. And do ls. Back to your local computer. I'll show it later. Did you build the
showing this, yeah. So we have to do the command to, the next would be the command to get it on the desktop. Oh. CPU.
have to transfer it to your.
Is that what this is doing?
Um,
Looked at.
No, this is from what we did in homework.
I will.
Just a second, I want to announce it for France. You got this? Oh, you already downloaded it. Okay, so now there is a three. In my native alphabet, there is no sound TH. So I have like thrilling. There is a thrilling question of how to download the file back to this local computer and plot it. So you can, there are barriers for logging into NERSC from outside, but there are no barriers, less barriers to log and make file transfer from NERSC to somewhere. So what I suggest is to do spe.pdf, or maybe just everything that ends with PDF, and then giving the credentials of my user, whatever username at CHEM676 North Dakota edu, and here, if I have forgotten, I need to and then I need to give path to where I want to so before I hit enter, I'm taking all PDF files from this directory on NERSC and transferring them to the user, this user at this cluster at this path. Home user CHEM676 user / subdirectory. Okay? Finally, I remembered which general comment I wanted to give. Please try to create separate, independent subdirectory for each molecular model you are working with. First, it will prevent overwriting of files, and second, it will help you to organize things. You'll be trying several models, and if you do not create subdirectory for each of the models, it may create disorder in your organization. So I'm going to hit enter. Name not known. Everyone makes. Yes. Let's try once again.
1+ point.
Yeah, for sure. Okay. So file was transferred successfully, and now I'm going into another window where I'm on the photo. And I do see that this spe.pdf appears there. Now I can either practice SCP or use this trick for the left bar where it shows where I am, and there is this sp.pdf. Okay?
Go back to the other.
Oh, absolutely. So this is what we just created.
Yeah.
So it has no absorption here, and it starts at about 3.2, right? And this is the profiles like this is what people get on UVV's experiments, and if you want to start your independent, stop class, stop school, and just be independent researcher, you just measure UV spectrum, compute absorption spectrum with VASP, put two figures together, and submit to a journal. Right? It works.
Good money.
Huh?
Money. Would it bring good money?
No, not money. It's
Prestige.
yeah.
Need something to keep it up.
For money, you find some industry that
Okay,
makes
yeah.
optically active materials, and they
Yeah.
tell, hey, I can predict properties of your
Go work
materials.
for
If you,
IBM.
I recommend starting with the motherboard. Once you've gone through that, you might start running your top.
Can we see that?
yes. You wanted this one?
Yes.
Well, okay, my
Oh.
understanding is here, just, I understand you're copying all the PDFs from that file, right? So shouldn't I be copying my information?
I'll make a circle and make sure that we all are on the same page.
Will we discuss to make the nanometer plot?
What?
Will we discuss to make the nanometer plot, because we're doing this.
Oh yes, absolutely, absolutely.
I think I had kind of a cold.
Okay, I'll put tops that it doesn't hold me off, but here is this line. And you put your name here.
Oh,
This is what we want to
aha.
Yep. And open another window. Wait, maybe you didn't open the subdirect, which I assumed. So I'm going to do
Oh, duh. Yep. Thank you very much.
And now you are a certified instructor, you can walk around and teach others.
That's right. Certified instructor. Nice. I don't think that's
Support myself by action.
You want need any help?
Yeah, so you have not made this folder in sorry. Yeah, you're right. So it should correct up on here. I'm saying right here. It's that. Yeah. Actually over here, that's refresh. Oh, you have to go to CHEM676.
So, certified instructor knows his work. Good. Good figures. In your structure, you still have two.
No.
Manually remove them and probably huh? You know that you can edit files without just in the postcard file.
You can take stuff out of with just removing it.
Well, no, you just remove atoms and change number of oxygens. Like, it starts alphabetically like HO, T, 24, 6, 2, and you've got probably 4, 8, 6,
I
Good.
thought, yeah.
Super. So, I already kind of learned who did US Spectre. Then Mary and Dave. For others, it is just like a fairy tale. But if you do experimental UV spectroscopy, typically they use x-axis in favorite spectroscopic units, which are not white.
It's transition energy.
So we are doing transition energy and electron volts.
Nanometers.
Nanometers, wavelengths, right?
Yeah.
What is wavelengths in respect to transition energy? Are they related or it's two random things?
No, they're related.
Huh?
They're related.
So how the wavelengths is related to transition energy?
In the inverse.
Yes, with which conversion factor?
Oh, it's close.
NC by NC.
Velocity of light.
Light.
And if we are converting in units from electron volts to nanometers, what is the numerical value of a constant?
There's 27. That's 2 electron volts. These are 27. Right?
And
Oh, I'm sorry. I was thinking atomic units to electron volts. Never mind.
if you're converting from electron volts to nanometers, what is the numerical value of conversion factor? I was once on the.
Isn't it power?
No, it's lambda equals some constant divided by electron volts, and this constant is. I was once on in the doctoral committee, and other committee members were trying to expel a student from the school because he was not able to represent this committee.
I think it is okay, but some people are very sensitive. It's probably good motivation to look online. Huh?
1240.
Yes, you are for sure in credit school. Maybe 1241. So 1 electron volt corresponds to 1240 nanometers. Okay? 2 electron volts correspond to 1240 divided by 2. How many? 1240 divided by 2. Yes, yes. So for visible range, I'm not in grade school anymore, so I don't need to memorize things. But about yellowish or greenish light is about this 2 electron volt and 600 nanometers. So it is a great range for visible experiments. So for us in computation and theory, units are not so important. But if you want to publish and get not money but reputation, you need to satisfy whatever people measure in experiment. And nanometers are right units. So in the so you do the same (1241) divided by EG minus EI. Okay, so if this equation is rearranged this way, it will show x-axis not in transition energies but in nanometers. So you see, it's not a big challenge to change in the codes, right? And if you look into the file spectrum, you do see the second column is transition energy in electron volts, and first column is wavelengths in nanometers. See, 1 corresponds to 1240, right? So, good. So, what if we do a little modification and do SPE nanometer? So, what? So the only difference is that it plots this file using first column as x, right? And then you do this. You see LS minus LT. There is a SPE nanometer, and you do in PS to PDF convert. Nanometer. And then you do have this file in PDF format. So now I'm practicing the same command for transferring files. here is the outcome. So the gap in a range of 3 electron volts would approximately correspond 1,200 divided by 3 for 400 nanometers. So it is about the edge of the visible range. So here will be like blue and purple, violet, and here starts ultraviolet. So this material will be colorless, but on the UV spectrophotometer you will see this peak. So please try to generate this figure as well. And I'll make a circle.
Only should I have, following everything, I just missed the step of creating the SCE. That's all it is, because I don't.
That's it. That's it.
Okay.
And then
Okay.
convert it into PDF.
I thought we already had it created. So.
What is it?
I'm lost.
Okay. So we are just repeating absolutely the same state.
You okay over there, Queen?
So because this is a new thing, I should have a whole new folder?
No.
No, because we named it differently, I don't need to put it into a different folder.
Correct, and you're using the same data, you're just making it a different conversion.
I got you. So what's the difference? Why is this creating this as
Because remember, we had things in electron volts.
Mm-hmm.
It's the same data, it's just, so here's our electron volts. This is our nanometers. Some people like to see electron volts, some people like to see it in nanometers.
Mhm.
This is how you're normally gonna show it. And this stays the same, this is an arbitrary data.
Perfect, thank you.
You're welcome.
And then, what do you want? What do you want?
If he wants to know the time.
Sometimes
I used to wear a watch, but I hated things on my wrist. That's why I can't wear necklaces. Yeah. Also, those ones tend to like pull hair. I don't know how you stand it, sometimes you can pull your hair on your arm. Cause it's got the parts, the bendy parts to it. Doesn't it? Okay, some watches do. Yeah. If it's a good quality watch, it shouldn't pull hair, that's for sure.
I didn't understand.
Yeah, it depends on the brand.
I would get a calculator one. That's the only thing. Watch out with.
That's the nerdiest kind you can have.
That's
true.
and have them both ends.
Constant copying.
I have no fascination for it.
Huh?
I have a fascination for those. I can like buy and sell those.
Oh, there's nothing wrong with that.
I have a couple of those.
I can't believe Dr. Webster has a posted grade.
Yeah, I know. That's driving me nuts.
It's crazy.
It shows how much he cares about us. Right?
Okay, so we are done with spectra, and we need to do periodic boundary conditions and orbitals. So I will take a couple of minutes to prepare demonstration so that it will go quicker. If you want to use your time with benefit, you may try to make the spectra for perovskite cluster, which will be like part of the whole thing. So just repeat it.
We should be following along, or?
I will repeat the same things.
Okay.
I just do not want you to expire your patience when I'm trying different options. Okay, so it needs a little more preparation step, but I'll explain the idea and we will try our luck. So suppose that we want to depart from isolated molecules to periodic solids. And we are going to do it with the simplest possible example. If the majority of audience will be like chemical chemists, we may took like a polyenes or polythiophins, but here we may try titanium dioxide ultra thin nanowire. So the right now we may arrange periodicity along y direction, and for pure test and experiment it would be better if model would be rotated to be aligned so that these titanium atoms will go strictly along y-axis. And I would do it if I would prepare it a little ahead. But right now let's do a quick thing with understanding of possible risks. So you do see, if we play with this model, that to upkeep the tetrahedral coordination between oxygens and titanium, the next titanium looks like it is rotated by 90 degrees, right? You see it? And if we want to build periodic image, periodic repetition, we know the stoichiometric formula that is stable, titanium O2. Right now we violate it in this molecule. Therefore it is not oxide but hydroxide. We have 6 oxygens. And if you want to keep, so because of this alternating angles, we need to keep 2 titanium in the unit cell. And titanium 2 times 2 will be 4, and 4 oxygens. So what I suggest we remove, we will believe that these 2 oxygens and these 2 oxygens are the same, that they are periodic replicas. And then it continues to go further, right? So we can keep these 2 oxygens and then we remove these 2. And of course remove all hydrogens. And then the image needs to be, to have the same length along y-axis as distance between these 2 oxygens. Does it make sense? Okay, so with my best ability I will try to practice it. But because the angle here is not ideal, the optimization may not go perfectly. But so we may get corrupt, wavy nanowire. Okay? So what I did, I opened it on a photon with JMO. And you may try your luck and do it. Maybe you do it better. Where did I get this geometry? I converted the VASP output into XYZ. This is also this was one of the questions. Let me bring it up just in case. So there is a script pos, means poscar 2 xyz.pl, and then you tell that concar, which is the last file created by VASP upon optimization, upon clicking this command, it's -LT, it creates concar.xyz, right? And it is, I understand, it is a challenge to remember this long line. It is not possible for normal human. So it's not possible for me. I'm getting, copy-pasting this long line by asking module show VASP. So it shows everything that is related to VASP on the system. And why do I identify that I need this line and not other lines? Because the name for this stuff is VTS scripts. If you look online for useful scripts to process VASP data, you'll find University of Texas Austin group, where simple people like us decided that VASP is not user-friendly and decided to make it a little sweeter. And then everyone can download it, and NERSC people also downloaded it on their system. But, so I'm copying this line and doing Perl, then this long path, and then post to xyz.pl. If you look inside this directory, you'll see like 100 useful scripts that if you spend more and more time with VASP, you'll find them more and more useful. And then after that, I did practice copying this file from NERSC to Photon. And then in Photon, we can open things for visualization. Good, good, good. Yes, I'll show it in a second. Just want to show the JMO.
So we're creating the contact file in our folder.
Yes.
And the next thing is SCP.
Yeah, you're transferring them out, so you're creating XYZ coordinates. Then you're doing the same thing you did with the previous thing.
I know the last homework was a little too compressed and challenging, but the idea was that you'll learn things like that in the homework, and now will come with this skill. And now you have become an instructor. So first there should be space here. And second, you need to translate from coordinate XYZ, so if you do the one, just press that. JMO is better, but I don't know. Me too.
Oh, you do this in Photon. You do the JMO in Photon. No, you're currently doing NERSC.
So while on the JMO, you may want to you see display most by definition it has perspective depth that is looks artistically but not very helpful. So I'm checking perspective depth and putting axis and bounding box. And then measuring distance between these two oxygens because it will be size of our measure distance and clicking on these two oxygens. Click, add to measurement list. So 4.8. This is the number that I may need, well, not may, I need for sure upon converting it, making it periodic.
Why is it different menu than yours for some reason?
You have newer version.
Is that bad?
No.
I'll just check. Can you get the signature in yours?
Oh, wait, where are you going?
Oh, you were doing this season.
So it should be able to press that too.
And we'll go to the tag, the email separately.
Okay.
Result posted. Oh my gosh. What a terrible mistake.
Nope, stop. How?
One side is 4.8 and the other side is
What?
4.7.
What?
One part is 4.8 and the other part is 4.7.
The angle compared to y-axis is so much deviating from ideal so that these little things will not affect. So you can put maybe between them, but 4.8 is a good starting point. So I'm going to remove 4 hydrogens and two terminal oxygens, and then convert this structure into periodic nanowire. So I'm selecting this red cross, deleting, rotating, deleting, and then delete this, delete that.
I don't have like the ability, I don't know if I have the ability to delete.
Because you have much more abilities.
Okay.
So I'm intentionally offering obsolete version, which is a little easier to use and comprehend.
Okay.
And then I need to save this file.
So wait, you deleted stuff?
Yes. I deleted so that now it is stoichiometric, right?
Okay, so, okay.
And after I'm saving under new name, like sort.xyz. Save.
I thought you messed up. And, okay.
And note, I have created new directory for titanium dioxide periodic because it will be new model and I do not want to mess up with old things, with previous model. So I'm going there and saving it as sort XYZ. More sort XYZ. So now it has only 6 atoms. And in this directory, in fact, I want to remove all files except this one. So they do not distract me. I remove all Oscar, all Concar. So I have only the sort XYZ that contains only 6 atoms. Now I am it is already arranged. So in fact I do not need to do the operations that I'm doing. I'm just inclined to follow the same protocol every day. So Oscar XYZ, it's the right format. First is number of atoms, second is command line, and then all oxygens first and all titanium second. Now if I just do not want to make errors on the fly, but it would be great to put right angles so that it will be oriented along y-axis. Rotate. XYZ. But I will do no rotation, and it will be a little wrong. And now I'm doing think to wasp. Postcard rotated. Postcard. First, I'm putting 0, 0, 0, but it doesn't mean that it is correct. I'm doing it intentionally. So we are going to apply periodicity along y direction. And for x and z, we are going to put a lot of vacuum. So right now, it shows that along y direction, the size of the model is 3.7 angstrom, right? And we noticed that unit cell should be about 4.8. We are coming about too close to completion because probably you are tired and it's time to wrap up. So, but it is an important thing. If you are sleeping, wake up. Okay. So we measured that ideal cell should be 4.8 angstrom, and here this command shows that our minimalistic box along y-axis is 3.7. So 3.7 is not sufficient. We need to put such number, such adjustment that will make it 4.8. So I just made an educated guess of 0.8, and then it shows that the along y direction is 4.8. But more rigorously, there is a way of running BC, which is board calculator, and do careful subtraction, like 4.8 minus the number that comes in here. So the correction should be a little different. Okay, so right now I do have a postcard file. So this postcard file is periodic in y direction, and it has a lot of vacuum in x and z. I know that it is not ideal model to start with, but it should be reasonable to practice. So I'm going to put in car k points and create pod car and start optimization and see what happens. So for pod car, how do I do it? So on the photon, there is also, yeah, I copied this POTPB, so the potentials are here. So cut. Oxygen, pod car, bigger, pod car. And second element is titanium. So I'm not using previous pod car because it contained hydrogen. And now I'm doing sanity check. Grep, PVE, pod car. So it has. No. I did wrong thing. Run. Instead of ls, I need to do cut. 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 Good. Checking once again. Yes, good. Pod car for 2 elements. Now I'm hopping from binary with template for k points and template for in-car, and naming it in-car. And checking that it doesn't have any stupid things. So first, I'm running it without geometry optimization just to create healthy wave car with subsequent optimization. And to avoid any explosions, I put very small protein. Saving, binary. Ideally, I should transfer it to cluster and run it there, but for such small model, I can run it here local in photon. So here is the command: binary wasp-photon. And remember from Hartree-Fock theory, there was a flow chart, right? So it shows how much of this flow chart it went through. And then writing wave function, so it is completed. ls minus OT. So there is a out car and OSI car. Now I'm copying cont car into post car. I understand it is a little quick, but we cannot do. We'll continue next week. I'll just sketch, and maybe it will be recorded. copying concurrent to postcard. VI in car. And now making it a little bigger step and putting, not very ambitious, maybe 10 points of optimization. It will be not full optimization, but just to check if you are in the right direction. Then again, running VASP. So it instead of, see, number of cycles become much smaller because it took previously created wave current, read it started where it stopped. So I recorded 10 steps, and they should complete as we see it here. So at the end of electronic steps, there are additional steps for geometry optimization. So when it writes this 4f equals, it slightly changes geometry and goes forward. So 5, and I have ordered 10 steps. And 6. And two more. So the benefit is that it works right away, but the disadvantage that if you have bigger system, you expire your patience. And step number 10, writing wave functions end. So now I'm very curious if it did anything good to me, not to me, to the model. So I'm taking the copy of this tools XYZ, and this command that we all may benefit now and in the future. It does create file named movie. So if you look inside of this movie, you see there are snapshots of the geometry during the process of optimization. And I may want to go to CHEM676 and open this movie file and then animate, which will scan through steps of the optimization. So it gets smaller and see it automatically slightly. I hope that it will rotate in the right direction. Well, it is not yet done, so we did only the first steps. But maybe it would be reasonable to continue if time allows. Now, tail minus M300. So let's see how did it do with the gap. Well, at least it didn't make too much of bad things. So the gap became smaller, but it's still open gap semiconductor, right? So what we did right now, you may not believe, but it is a model of an infinite periodic nanowire. I think we should end now. Please lift hands if you want me to make last round and individual help. And if not, let's postpone it for the future. So I'll try to design and announce homework maybe a little smaller than previous one. And meeting is complete. Looking forward to see you tomorrow at 6. Yes?
I sent you 3 files. Ignore the flexible primer just to look at it, but I'm not doing that project. It's relevant to my